day mga ka-co-learners. This is Mighty Math TV. I am Osin Janel Dulay, your co-learner.
I am Carlinho Evalle, your co-learner.
I am Angel Jeline Asunero, your co-learner.
And for the objectives of this video are: first, illustrate the 6 trigonometric ratios. Second, apply trigonometric ratios to solve right triangles given. A. How to solve for hypotenuse. B. How to solve for sine. C. How to solve for cosine.
Our lesson for today is the 6 trigonometric ratios. But first, we take a quick review on what is trigonometry. What is trigonometry? First, it is the branch of mathematics that deals with the relation between the sides and angle of a triangle. Second, it is from the Greek words trigon, trigon meaning triangle, and metron, which means to measure. It literally means measurement of triangles. Third, it is a tool used for measuring distances that cannot be directly measured. Fourth, trigonometry involves the study of angles and geometric ratios. Now that's done, let's have the first basic concept of trigonometry. What is right triangle trigonometry? It is often used to find the length of one side or the measure of an acute angle of a right angle. We have hypotenuse, opposite side, and adjacent side. Hypotenuse is always the side of opposite the right angle. It is the longest side of a right angle. Cannot be the opposite side or adjacent side. Opposite side is the opposite side of an angle. Adjacent side is the side where the angle is from. Let's take triangle ABC and identify the hypotenuse, opposite side, and adjacent side. Respecting angle A. Angle A, opposite side equals A, adjacent side equals B, hypotenuse equals C. Now that we know what is right angle trigonometry is, let's have Austin Jan Dulay for the basic concept of trigonometry.
The 6 primary trigonometric ratios are sine, cosine, and tangent, and the reciprocals are cosecant, secant, and cotangent. Sine is opposite side over hypotenuse. Cosine is adjacent side over hypotenuse. Tangent is opposite side over adjacent side, and the reciprocal of sine is cosecant, and their hypotenuse over opposite side, and the reciprocal of cosine is secant, and the hypotenuse over adjacent side. And lastly, the reciprocal of tangent is cotangent, and well, you guessed it, it is adjacent side over opposite side. We can remember them in the mnemonics: so, ka, toa. So for sine, opposite side in hypotenuse; ka, cosine, adjacent side in hypotenuse; and toa for tangent, opposite side and adjacent side. And lastly, the marking symbols to identify which angle is the 6 trigonometric ratios. And the symbols are theta, alpha, beta, and just the angle with the unknown value, or just unknown value and the value of the angle.
And now we know the basic concept of trigonometry. Let's apply both that we've learned. Let's have Austin Jan Dulay for the examples.
Now, let's apply the things that we have learned in the discussion on the basic concept of trigonometric ratios. Example number 1. Determine the trigonometric ratios of angle C in the triangle ABC. First, sine C. If we take a look at angle C right here, we would see that its opposite side is 4. So, we know that the sine is opposite over hypotenuse. Because we now know that the opposite is 4 and the hypotenuse is 5 because it is directly in front of an right angle. In the right angle B, right here, and its opposite side is the hypotenuse, which is 5. Now our sine is 4 over 5. And now let's answer cos C. We know that the cosine is adjacent over hypotenuse. And the only remaining side here is 3, directly in front of A. And we know that the side that is near to the angle of what we look at is the adjacent side, and the value of it is 3. And the hypotenuse is 5 again. And if we answer tan C or tangent C, we know that tangent is opposite over adjacent. And our opposite is 4. And our adjacent is 3. It's 4 over 3. If we answer cosecant C, we know that it's the reciprocal of sine C. So 5 over 4. And same for secant C, but it's for cosine. It's 5 over 3. And if we answer cotangent C, it's the reciprocal of tangent. So it's 3 over 4. And now we know. And for example number 2, let's determine the length of the missing side of the triangle XYZ. The missing side here is x, and we need to find its value or length. We use Pythagorean theorem to answer this. And the Pythagorean theorem is c squared is equal to a squared plus b squared. And c squared here is the hypotenuse here, x, because it is right in front of a right angle. So it's x squared is equal to a squared plus b squared. And who are they? A squared and b squared. These two are the adjacent and opposite side. They can be either both of them, so you can switch them up. So x squared is equal to here 13 and 11 squared. Let's square it to both of them to cancel out the square here in x. So the left is x is equal to square root of 13 squared plus 11 squared. So, and let's answer them now. So x is equal to square root of. So what is the square of 13? It's 169 plus what is the square of 11? It's 121. What is the square of 290? It's, oh, we can square. It's not a perfect square. So this is the final answer. X is equal to square root of 290. For example number 3, determine the value of 6 trigonometric ratios of theta in the triangle PQR. In this example, we incorporate the ideas of example number 1 and 2. Our missing side is Q. To solve this, we use the Pythagorean theorem, and that is c squared is equal to a squared plus b squared. Again, c squared is the hypotenuse, and our hypotenuse is q because it is right in front of a right angle. It's q squared equal to a squared plus b squared. Now, let's replace their values. U squared is equal to 8 squared plus 6 squared. And let's square the both sides. Let's square the both sides of them to eliminate 2. Now, we're left with q is equal to square root of 8 squared plus 6 squared. And what is the square of 8? It's 64. And the square of 6 is 36. (64) plus 36 is equal to 100. And let's square the 100. And what is the square root of 100? It's 10. Now, let's dive into the next part. Sine theta is equivalent to opposite over hypotenuse. And our opposite side is 6. And our adjacent side is 8. And our hypotenuse is 10, as we solved earlier. So it's 6 over 10. Because again, the value of opposite side is 6. Next is theta. It's adjacent over hypotenuse. And our adjacent is equivalent to 8 and our hypotenuse is 10. And next is tangent theta. And the formula for tangent is opposite over adjacent. And the value of them is 6 over 8. We know that the cosecant is the reciprocal of sine. So let's just switch them. It's 10 over 6. Same as for cosecant, but for cosine, it's 10 over 8. And for cotangent is the same, but for tangent, it's 8 over 6. Can we simplify all of them? Yes, we can simplify them because we divide them by 2. We'll have 3 over 5. And same as for the cosine, we can divide by 2. We'll have 4 over 5. Same as for the tangent, we can divide them by 2. 3 over 4 or 3/4. Same as for cosecant, we can divide them by 2. It's 5 over 3. Same as for the secant, we can divide them by 2. 5 over 4. Same as for cotangent, we can divide it by 2. It's 4 over 3. And now you know. And for example number 4, determine the trigonometric ratio of angle E and the triangle EFG. It's the same for the example number 3. But what if one side had a radical sign on it? It's the same as before. We can answer it by just having this. Let's use the Pythagorean theorem to answer this again. It's c squared equal to a squared plus b squared. So our hypotenuse is f because it is right in front of a right angle. So it's f squared is equal to a squared plus b squared squared. Let's square it again. Here, let's use this. Then plus 3 squared. So eliminate the radical sign. We're left with f is equal to eliminate the radical sign for 10 and let's square the 3. It's 9, 10, and 10. So f is equal to square root of 19. And that's our answer for the missing value of f. And now, let's answer the trigonometric ratio. But first, we must identify the adjacent, opposite, and then the hypotenuse. The opposite of E is 3, and the adjacent side, we're left with the square root of 10. And the hypotenuse is here, square root of 19. Now with that information, we know that the sign is opposite over and say hypotenuse, and our opposite is equivalent to 3, and our hypotenuse is square root of 18. We can't have any radical in our denominator, so what we'll do is multiply it by what we're having as a denominator, square root of 19. Square root of 19. Our answer is eliminate them. We're left with 19. And 3 times square root of 19 is just 3 square root of 19. And this is our answer for sine E. And for cosine E, it's just adjacent over hypotenuse. We know that the adjacent is square root of 10. and our adjacent hypotenuse is square root of 19. Same as before, we're having a radical sign as a denominator. We'll just multiply it by what's in the denominator. It's square root of 19. Then square root of 10 times square root of 19 is square root of 190. Because they are the same, they have radical sign in them, and we'll just eliminate the radical sign for the denominator. It's just 18, and for tangent A, it's opposite over adjacent. Our opposite is 3, so our adjacent is square root of 19. Oh, it's just square root of 10. Ito tulapit ito. And for our tangent, it's opposite over adjacent. And the value for our opposite is 3, and our adjacent is square root of 10. And same as before, there's a radical sign on it, and we'll use that denominator to multiply both sides. That's 10, 10, eliminate here. That's it. 10. Here, 3 times square root of 10, it's 3 square root of 10. And for the cosecant E, it's just the reciprocal. So here, 3 over square root of 19. It's 19 on above, it's 3 on below. And we're having a full number here. So we'll skip the last process in for here. For second, it's square root of 19 over square root of 10. We do the same as before. We multiply by what's on the denominator. It's square root of 10. And 19 times square root of 19 times square root of 10 is equal to square root of 190. And here it's 10. And for cotangent, it's just the reciprocal of tangent. It's square root of 10 over 3. We don't have any radical sign below, so we'll skip the last process. And now you know. Example number 5. Given tan theta is given to 5 over 2 square root of 6. Find A cos theta and B tan A. First, we must find the missing side. It's the hypotenuse. Hypotenuse is x. You can solve x by using the Pythagorean theorem. It's c squared is equal to a squared plus b squared. C squared is the hypotenuse, so it's x squared is equal to a squared plus b squared. Now we can replace the value. It's 5 squared plus 2 square root of 6 squared. You can square both sides. So the remainder is x is equal to square root of 5. The square of 5 is 25 plus the square of 2 is 4. The square of 6 is 36. 36 divided by 6 is 6. So x is equal to 25 plus 4 times 6, it's 24. 25 plus 24, it's 49. The square root of 49 is 7. So our x is equal to 7. Now we can solve cos theta. Cos theta is equal to equals to adjacent over hypotenuse. Our adjacent side of theta is 2 square root of 6 over hypotenuse. Our hypotenuse is 7. Next is b. It's tan A. Our tangent is given to opposite over hypotenuse. Our opposite side to tan A is 2 square root of 6 over over adjacent side. Our adjacent side is 5. Now you know.
This is the end for our video lesson on the 6 trigonometric ratios.
And now you know!